Hey everyone, and welcome. Have you ever stopped to think about all the changes happening around us, literally all the time? I mean, from the toast you made this morning to the fireworks lighting up the sky, what's behind all that? Well, the answer is chemical reactions. They are the engine of our world, happening all around us and even inside of us every single second. So let's kick things off with a super classic example.
Okay, picture this. You strike a match. Super simple, right? You see the flame, you feel that little burst of heat, and the wood just turns into ash. But what's really going on there? I mean, on a level we can't actually see with our eyes. What is really happening when that match burns?
Now you might just say, oh, it's just burning, but it's actually so much more than that. The wood of that little matchstick is going through a complete and total transformation. It's literally becoming something brand new with a whole new identity. And today we're going to figure out exactly how that works.
So, to really get this, we've got to put on our detective hats for a minute. Think about it. How do scientists, or heck, even old-time gold prospectors, tell one substance from another? Well, they look for clues, right? Clues hidden right there in the matter itself.
How could you tell a real gold nugget from a piece of fool's gold, that shiny iron pyrite? They might look pretty similar at first glance, but a smart miner would know the difference instantly. How? By checking their properties. For example, real gold is way heavier for its size. That's a property called density.
And that brings us to our first big idea, a physical property. So what is that? It's basically any characteristic you can observe or measure, with your eyes, your hands, whatever, without changing what the stuff is actually made up. It's kind of like describing a substance's personality.
So we're talking about things like its color, its texture, how dense it is, even the temperature where it melts or boils, or, whether it can dissolve in water. Think about water, right? It can be ice, it can be liquid, it can be steam. Its physical state changes, but it's still H2O. Its identity hasn't changed one bit.
Okay, but here's where it gets really interesting. Some properties don't just describe what a substance is right now. Instead, they describe what it could become. They're all about its potential to change into something else entirely.
And that, my friends, brings us to chemical properties. A chemical property is all about a substance's ability to change into a new substance. Take an iron nail, for example. The fact that it can rust if you leave it out in the rain, that's a chemical property of iron. It's describing its built-in potential to turn into rust.
So a couple of great examples of this are flammability, can it catch on fire, and reactivity. Reactivity is just a fancy word for how likely something is to react with something else. Just like how that iron nail reacts with air and water to create that classic reddish-brown rust.
Okay, so let's recap. We've got physical properties and we've got chemical properties. Got it? Cool. Now let's use what we know to break down the two main ways that matter can change.
All right, check this out. It's really simple when you see it side by side. On one hand, you have a physical change. That's when the identity of the stuff stays the same. Melting ice is the perfect example. It's still H2O, it's just in a different form. But then you have a chemical change. This is the big one. A totally new substance gets made because the atoms themselves actually get rearranged into new combinations. When that nail rusts, the iron atoms are literally linking up with oxygen atoms to make something new, iron oxide. That is a chemical reaction. So we know a chemical reaction is all about atoms rearranging to make new stuff. But, there's a problem. We can't exactly see tiny little atoms moving around. So how in the world can we tell when a reaction is actually happening? Well, we have to go back to being detectives and look for clues.
Yeah, this is where your detective skills get put to the test again. Let's say you're mixing some things together, maybe in a science lab, or maybe just baking a cake in your kitchen. What are the signs you'd look for that tell you, hey, this isn't just mixing anymore, something else is going on?
Well, you'd be on the lookout for a few key things. For instance, is there a sudden color change or a new smell you weren't expecting? What about bubbles? Are bubbles fizzing up even though you're not heating anything? Or maybe there's a release of energy, like the heat and light from a campfire. And here's a really cool one. Sometimes a solid will just appear out of nowhere when you mix two clear liquids. That's called a precipitate. But hold on a second, this is super important. These are just clues, okay? They're not 100% proof. I mean, think about it. Bubbles also show up when you boil water, and we already said that's just a physical change. The only way to be absolutely positive that a chemical reaction happened is to actually test what you've made and prove for sure that it's a new substance with totally new properties.
Okay, so this is all really cool science, right? But why does it matter in the real world? Well, it turns out that understanding and controlling chemical reactions can literally be a matter of life or death.
Let me ask you this. How can chemistry save your life in a car crash? And I'm not talking about the seatbelt, though you should definitely always wear one. I'm talking about something that happens in the blink of an eye.
The answer? The airbag. And what is an airbag, really? At its heart, it's just a bag that inflates because of a perfectly timed, unbelievably fast, and super powerful chemical reaction.
So here's what happens. It's crazy fast. The moment a crash happens, a sensor triggers an electric signal. That signal tells a chemical inside, sodium azide, to react. And bam! It instantly breaks down and produces a massive amount of harmless nitrogen gas. All that gas inflates the airbag faster than you can even blink, creating a soft cushion to protect you. It is a perfectly engineered, life-saving chemical reaction.
All right, so now that we've talked about properties, changes, and even life-saving reactions, let's bring it all the way back home. Let's go back to where we started, that mysterious burning match. Remember what we saw? The wood turned black and crumbly. We saw a bright flame and felt heat. We could smell the smoke. All of those things we saw, they were our clues. They were telling us that something major was going on.
And now here's the final answer. That ash left behind, it's not just burned wood. It is a completely new substance. I mean, think about its properties. Can you light ash on fire again? Nope. It has a different color, a different texture. It's totally different. And because a new substance was created, we can now say for certain, burning is a chemical reaction. Case closed.
So that just leaves us with one final thought to chew on. From the food digesting in your stomach right now, to the leaves on a tree outside turning sunlight into energy, our entire world is powered by these incredible invisible transformations. It makes you wonder, doesn't it? What other chemical reactions are happening all around you, right at this very moment?